Cool. So any question here about the arc length and area? All right, no question. Example, sine of x. So sine of theta equal to 1/2. Good. The question is, given sine of theta equal to 1/2, find sine of negative theta. So should I make a multiple choice? Is that A, 1/2, or B, negative 1/2, or C, 2, D, negative 2? Which one should we pick? Jason, looks like you're already
B.
B, negative 1/2. And you might be right. So one thing about this course that we need to visualize it. I know 1/2 is something that you have it on your note sheet, correct? Note sheet or on the unit circle, the table. So we have a circle here. That works. They're saying sine of theta is 1/2. So this 1/2 is positive, correct? So we know sine is positive on first quadrant, second quadrant. So 1/2 can be, and the table is 30 degrees. If this is theta, happens to be 30 degrees, this sine, this is the length of sine. This is 1/2. Now I said negative theta. That means whatever is this much, which in this case is 30 degrees, we're gonna go, this is positive direction, the other one is negative direction. So if I go here, so this will be negative theta. I agree. What is the sine of that? Is this length. So this is exactly same as that, but this is positive. This one is negative 1/2. All right. Any question here? So I'm gonna change the one. So this is, I call it here theta, correct? I could label it x. I could just say sine of x equal to 1/2, then find sine of negative x. I can change this one to k, t, whatever. Don't think always should be theta or alpha. No, I can label it xy. So when I say x, don't think I'm looking for this x-axis. There's nothing to do with that. X will be this guy. So this will be x, and this is negative x. All right. So don't pause your time. So why do we have x there? Doesn't matter. Sine and all the 6 trigonometric function, they get the angle here. We can label it anything we want. So now let's have another similar question. So the question is, given sine of negative t equal to 3/8, what is find sine of t?
-3/8.
All right, so A is 3/8, B is -3/8. Why did you pick -3/8? I mean, if you visualize it, we have sine of negative t. So we have negative, we're gonna go this direction, become positive. For example, it will land somewhere around here. Good. For example, this one. Let's say this is 220 degrees, -220. Good. We end up being here, and sine is positive. Now, sine of positive t, positive 220, it will go all the way over here. So it will be -3/8. So what we are learning for these two examples, we are learning that sine of negative x equal to negative sine of x. Is this true? And yes, this is true. And that means sine is an odd function. We learned about odd and even. We said a function is odd if f of negative x equal to negative f of x. Good. If it's like this, that means it's odd. The last two examples, we see that sine of like sine of theta was 1/2, then sine of negative theta become negative 1/2. So also in this example, sine of negative t equal to 3/8, sine of t will be -3/8. Any question about sine?
Professor,
Yes, Elizabeth.
so basically like if we're given any number, it's just the inverse. So it's like 3/4 of sine, then the inverse is just -3/4.
Not, yeah, you have it correct, but the way you said is not inverse. Just inverse means if it's like a 1/2, it will be 2/1. But
Okay.
we just change the sign. Yes. So sine of negative x will be equal to negative sine of x. That's the property of sine. Good. Example, sine of like x equal to 0.002. What is sine of negative x? It will be just because sine is an odd with this property. If it's negative here, this negative will pop outside. It will be sine of x. Sine of x is 0.002, so it will be -0.002. We just change the sign. Just change the
Thank you.
positive, negative. Let's have the same question about cosine. Given cosine of x equal to 1/2, find cosine of negative x. Is that A, 1/2, B, negative 1/2? Jason is ready with now.
Yeah, I mean, negative 1/2 seems it.
I catch you here. Well, let's visualize it. So we have a circle. And we have our x and y axis. Good. Again, 1/2 is something that we like. It's like a 60 degrees. So I'm going to make a 60 degrees here. This is 60 degrees. I'm going to call it x. Cosine of this is 1/2. What is cosine? I mean, this is x, that's y. So this, we said this is cosine, and that's sine, correct? So if you make a right triangle, this much, this guy is cosine. This length is cosine, correct, Jason? From here to there is cosine of x, which happens to be 1/2. Good. Now let's graph cosine of negative x. So this is positive direction, this is negative direction. So negative x, if this much is x, then negative x gonna be this much. Good, this is gonna be negative x. If you make a right triangle, what is cosine? Cosine again is here. Is this positive or negative?
That's bad.
Positive, very good. So I know I made it because to visualize it, but from now on, you don't need to graph it. Cosine will be even. That means, so the answer is positive 1/2. That means cosine of negative x equal to cosine of x. So cosine eat the negative. That's all. So this cosine of negative x here, because cosine is an even function, the answer will be same as cosine of x. If cosine of x is 1/2, then cosine of negative x is 1/2. All right, Karen?
So it's always gonna stay the same?
Or
Or
if you
it's
find
okay.
it somewhere which is not acting like this, you're gonna be famous. So far it's like this. Yeah, it's even. But only sine and cosine, but I can. So always sine is odd, always sine of negative x equal to negative sine of x, and cosine of negative x equal to cosine of x. Yes, always. But we we sometimes make the question a little spicy, a little complicated. Let's have one of those questions to make Karen happy. Example. F of x equal to sine square of x multiplied by cosine of x. Good, this is a function. That means there's something factory, it gets x and we have y. Good. We don't want to visualize it. I mean, this is like a function. But my question is this even or odd? Or neither? Even, odd, neither? Or none of it? So but even and odd, in our note sheet, what do we have? In our note sheet, we have sign of, let me deal with this one. So what do we have? So the question is about even and odd. In our note sheet or in the homework or the note sheet, I mean the lecture that we talked about, we have two things about even and odd. We know sine of negative x equal to negative sine of x, and cosine of negative x equal to cosine of x, correct? We know this. In order to decide that even and odd, we need to find f of negative x, correct? If f of negative x equal to f of x, then we're gonna say is even. If f of negative x equal to negative f of x, we're gonna say is odd, correct? If none of these two, we're gonna say neither. So in order to answer this question, we need to find f of negative x. Good. That means instead of each x here, I'm going to substitute negative x. So we're going to have sine squared of negative x times cosine of negative x. So I'm going to make this one negative x, negative x, negative x. Cool. All right. So now that we substitute negative x, now the question is what? So we have sine of negative x here. What is sine of negative x? Followed by this formula, sine of negative x is negative sine of x. So instead of, I'm going to say negative sine of x, and I'm going to put this one in parentheses and then square it because it has a 2 here, correct? What is cosine of negative x? Cosine of negative x is same as cosine of x because cosine is even. Good. So this 2, if you square it, the negative will go away. It will be just positive sine square of x times cosine of x. So what did we got? This one is exactly same as original function. Good. That means f of negative x equal to f of x, therefore is even. Do you see that, Karen?
Yeah, I was guessing since the beginning that it was gonna be even because it's square. Can you just like assume
No,
without making it
no,
work?
no. Don't come up with any shortcut. Enjoy this journey of solving algebra. No, there sometimes we have degree even. The even doesn't mean the degree should be even. No, sometimes, most, but there are functions that act crazy. So this is what you learned today. Even and odd. Sine is even, cosine is, no, sine is odd, cosine is even. So you put this on your note sheets. Good. But if I ask you guys, tangent of x, is this even and odd? Is that tangent of negative x equal to negative tangent of x or tangent of negative x equal to positive tangent of x? Is this even or odd? What do you think? If tangent of x equal to like 5/8, then tangent of negative x equal to what? Is it A, negative 5/8, B, positive 5/8? What do you think? Jason,
Negative 5/8.
all right, you like negative, and this time become true. Yeah, it's negative. If it's like this, that means tangent is odd, is this one. So tangent is odd, but you don't need to put it in your notes. You don't want to fill up your notes. You just sine and cosine is enough. So it will be negative 5/8. If I ask you why is that, then we can prove it. Why? Because we're going to go back to sine and cosine. Look at tangent of x. This is same as sine of x over cosine of x, correct? That's the identity of a tangent. Now I'm going to find tangent of negative x. It will be sine of negative x over cosine of negative x. Agree? What do we know about sine of negative x? We know sine of negative x is negative sine of x. What do we know about cosine of negative x? Is equal to cosine of x. Cosine is the negative. So now what do we have? We have negative sine of x over cosine of x. What is sine of x over cosine of x? Is tangent of x. And we have the negative. So tangent of negative x equal to negative tangent of x. That means is odd. That means the negative gonna go outside. All right, so again, the point is I would like you guys just know about sine and cosine, about even and odd. Whatever I ask you guys, you can just convert it. All right, let's have another type of question. Okay. Another question is, I give you guys a circle, a unit circle. Unit circle means the center is 0, 0, not straight. Unit circle means the origin here is 0, 0, good, x and y. And also we know radius is 1, r equal to 1. This direction is plus and that one is negative, you already know. We already know that this is 0, pi half, pi, 3 pi half, and 2 pi, correct? 1 revolution. Now I'm gonna make it a little spicy question for you guys. The question is, we have a theta. So we have a point here. the coordinate of this point is it will be negative 12/13, comma, let me see, and 5/13. All right. This is a point on that circle. And if I connect it, I will get this theta or alpha. Now the question is, they ask us find the 6th trigonometric value for the alpha. That means they are looking for sine of alpha. We're looking for cosine of alpha. We're looking for tangent of alpha, cotangent of alpha, secant of alpha, and cosecant of alpha. Cool. We know if you find sine and cosine, if you find this one, the rest of that, it would be super easy. It would be lovely because they're related to sine and cosine. So what is sine of alpha here? Noor, what do you think sine of alpha will be?
Is it 12/13?
Almost. So very good. I mean, you are in the right direction, but this is x and y. This is same as x is cosine, y is sine, correct? And
Oh,
this
yeah,
is
so
alpha.
negative 5/13.
So 5/13, yeah. And cosine of alpha will be negative 12/13. Now, what is tangent of alpha? You see that when we know it, is super easy. If you don't know it, you think it's like unbelievable to solve, and it's not solvable. So now, tangent of alpha is, we learn, is sine of alpha over cosine of alpha. Also, we learn tangent is y over x on the unit circle. We have that in your note sheet. So in this case, it will be negative 5/12. How did I get 5/12? I mean, if you divide this by that, the 13 will cancel, and then you get 5/12. What is cotangent? Cotangent is x over y, which happens to be negative 12/5. Good. What is secant of alpha? Secant is 1 over cosine of alpha, which is 1 over negative 12/13 equal to negative 13/12. Why did I put cosine here? Cosecant. Cosecant of alpha is 1 over sine of alpha. It will be 1 over 5/13, which is 13/5. So we solve the 6th trigonometric value for this coordinate. Again, this is, you already knew that. You could solve this one if you go through your note sheet. but I just made one question. I just want to tell you guys that, I mean, there are so many different ways we can ask you question here, the same thing that you know. Let's have another type of question. Another type is, for example, sine of t equal to 4/5. They're asking what is sine of pi minus t. So given this, find this. Is that, let's make it multiple choice for you guys because it's Wednesday. Is that 4/5? B, negative 4/5? C, 5/4? D, negative 5/4? Jason, what do you think? Jake, what do you think? Still connecting?
I mean, I'm gonna go with what I've been going the whole time, negative 4/5.
All right, man. Hopefully your portfolio is not negative today. Mauricio. Thanks, Jason. So you said negative 4/5, but Edison, what do you think?
Yeah, I'm gonna go with D. I think I could be wrong, but
No, don't be negative. Just no, don't be. But let's ask Yvette.
I think B.
So Jason has a lot of follower now. Did I ask Karen? Karen?
I'm just gonna go with what everybody else said.
All right. So most people say, I think, but we don't want to think, we're going to think logically. We're going to just follow the logic, correct? The algebra part. So they said, they are saying that sine of t equal to 4/5. So I'm going to randomly pick a t on the first quadrant because this is positive and sine going to be positive on first quadrant. So I'm going to make, for example, this much. I'm going to call this one t. All right. And this length here will be sine, correct? Is value of y. So this is 4/5. Now, where is pi minus t? Pi means you're going to go, what color should I pick? Blue is good. You're going to go, this is pi, correct? 180 minus t is going to come here. So, no. Oops. So this much is pi minus t. Is that, do you see it, Jason? For example, if t was, Karan, you're scaring me. What was that?
Oh, it was my buddy.
So I have a new student, t equal to, for example, for example, 75, correct? Well, let's make it 25 degree. Then pi minus t will be 180 minus 25. It will be 155 degree, correct? So if t equal to, if this is 15, then 180 minus t will be here. I just randomly pick an angle. Any angle you pick, if you subtract from 180, you will end up being in quadrant 2. So now with this knowledge, which one is that? Is that negative or positive? Is that sign, is that negative or positive on quadrant 2?
It's positive.
Positive. So Jason said positive, guys. So everybody gonna say positive now. So it will be positive. So it will be 4/5. It's nothing to do with even and odd. I just made a question like this. So it would be positive 4/5. Same question if I ask you guys what is sine of pi plus t. Now what's gonna happen? Is that 4/5 or negative 4/5? Jason?
Yeah, if you're adding 180, it puts you in quadrant 3, right? So that'd be
Excellent.
negative.
Negative, very good. So that's, you got it. So be any t you pick here, if you add pi, which is 180, plus t will be somewhere around quadrant 3. And quadrant 3, the sign will be negative. It will be negative 4/5. So that's the concept of this course. I mean, you cannot, I mean, if you have like a 10 pages of notes, you're not going to have the same question as a homework or same question as what I'm making example. You need to understand it. If you understand it, I mean, like this, but the way Jason said that, I mean, I can see he clicked. So good, we have to go to quadrant 3. Now, instead of sine, I can put cosine, or instead of pi, I can put 4 pi, 3 pi. So you know what to do. Let's have another question like this. I'm gonna make like cosine. Cosine of t equal to 4/5. I am looking for cosine of t plus pi. Is this A, 4/5, B, negative 4/5?
A.
Current A. Okay, I don't know. Let's pick. Let's see if A is correct. Cosine of t equal to 4/5. So cosine is positive. I can pick any. So if you know cosine is positive in quadrant 1 and quadrant 4, I can randomly pick any on quadrant 1 and quadrant 2, quadrant 4. But quadrant 4 is kind of confusing. I'm going to pick 1t here. Example. This I'm going to call it t. And the cosine of that will be this much. Good. If I make a right triangle, this will be, this length here will be cosine. Now I'm going to add pi to it. So this is pi, correct? Plus t. It will be on quadrant 3. Correct? Is it positive or negative? So it's got to be in quadrant 3. If you make a right triangle, this much will be cosine of pi plus t, which will be exactly negative 4/5. Because here is 0, correct? This is 0, 0. If you go this way is negative, that way is positive. Or you can say what Jason said on quadrant 3, cosine is negative as well. So Karen was wrong. But
Oh, it's because since earlier you said that cosine always stays the same, but it changes with the.
okay, that's good point. This is nothing to do with even and odd. If I ask you cosine of t equals 4/5, what is cosine of negative t? You're right. Cosine of negative t is, again, is positive 4/5. But I'm not asking you what is cosine of negative t. I'm asking you what is cosine of t plus pi. Good? That's a different question. Do you see the different question, Karen? All right. Any question here for the lab past 2 example? So visualizing is super important. Just looking at the question. Not like that, but you need to visualize it. Let's have another type of question. Another one is like sine square of theta minus cosine square of theta equal to 2 sine square theta minus 1. I can ask you guys, is this true or false? There's one type of question I might ask, is this equal to other side? Or I'm gonna ask, prove it. That means prove the identity. Prove that this side equal to that side. But for now, let's see it's true or false. Is that A true, B false? One of the questions is about this one. I asked you guys to prove identity. Another one is solving for a trigonometric equation. So when you see this type of question, you need to just be, fully of confidence, and you say you can do it. And the good thing is all of them are similar. So here I see sine square plus cosine square. In your note sheet, we have sine squared theta plus cosine squared theta equal to 1. We proved this, correct? There's something that identity, we proved it. But here is negative, so we cannot say equal to 1. But from here, that you see sine squared plus cosine squared equal to 1, if I subtract negative sine squared, both sides, I'm going to get another equation. I'm going to get cosine squared theta equal to 1 minus sine squared theta. Also, if I do the other way, I can get sine squared theta equal to 1 minus cosine squared theta. Agree? So from this one, 2 immediate formula is this 2. Cosine square is 1 minus sine square, sine square is 1 minus cosine square. So if instead of cosine squared theta, I plug this formula, I need to get rid of cosine squared because the other side there is no cosine. So instead of cosine squared, I'm going to put 1 minus sine square of theta. Inside of the parenthesis, because there's a negative here. So I use this formula. So for proving identity, you need to know, for sure it should not be any algebraic mistake, because if you do one small mistake, you're never going to get the other side. But if you don't do any mistake, you do just use different formula, you will get the other side eventually. So far, instead of cosine squared, I put 1 minus sine squared. Where is this formula coming from? Coming from here. So now let's remove the parenthesis. We have sine square of theta minus 1 minus minus will be plus sine square of theta. Sine square of theta plus sine square of theta, it gives us 2 sine square of theta. And this minus 1 goes here. So what do we have? We got 2 sine square minus 1, which is, if we go take it here, is exactly same as that. Good. So we proved it. Done. That's how we prove it. So you start with one side, you simplify to get to the other side. When you're done, you don't need to make a track. You just make a block. You say, oh, we are done. So I said proving identity is one of the complicated questions that you will see in this course, but the technique that we are using are similar. So one technique that we just learned, we're gonna use this property a lot, this property on the first identity.